Here is the molecule I chose to build for the Build Your Own Molecule project. So I chose to build and research a molecule called citric acid, also known as citrate. So you'll see to represent the individual atoms, I chose different colors of Play-Doh, and these wooden dolls here, kind of like the ones in class, for the bonds. So the pink ones found all throughout are hydrogens. The orange Play-Doh is oxygen, and then the green ones are carbon. The regular wood dolls here are just single bonds, and the black ones are double bonds. So citric acid is naturally found in foods such as oranges, lemons, and limes, but also added to stuff such as cheese, ice cream, and candy. So it's just used as a preservative in foods. It will prevent mold buildup and bacteria buildup, which will affect the survival of food. So these foods do not rely on citric acid to survive. They just need citric acid to survive longer. So the chemical formula for citric acid is C6H8O7. Citric acid has a boiling point of 310 degrees and has a melting point of 153 degrees, and that's all in Celsius. Citric acid is a relatively weak acid compared to other acid molecules, and the reason why the citric acid is an acid just in general is due to the positively charged H atoms. So the more positively charged H atoms you have, is the more acidic your molecule is. So you'll see just some examples right here. So we know these will be positively charged due to the electronegativity chart. So since it has a good amount of them, this molecule has a pH of 2 to 3, obviously meaning it's an acidic molecule. That being said, it's not a very strong one compared to other acid molecules. So it's a relatively medium-sized molecule. It has 21 atoms. Obviously, again, 6 of them being carbon, 8 of them being hydrogen, and 7 of them being oxygen. And then the structure has a specific name. It's called a monoclinic crystal structure. The reason why it's called that is because in physical form, it is seen as a crystal. So citric acid has 4 functional groups, well, it's 2 different functional groups, but in total it's 4. So you'll see here, one of them being a hydroxyl group. So we have one hydroxyl group, which is just an O bonded to an H. And then we have 3 carboxyl groups, which is C, double bonded to the O, and then an OH molecule. So we have one to the left here, one on the bottom, one on the right. And so this is soluble in water due to the OH groups in the citric acid. That group is a polar molecule, which will dominate the molecule, leading citric acid being able to form hydrogen bonds, meaning it can dissolve in water. Because you'll see here, even though we have carboxyls, within the carboxyls are hydroxyls, so OH. So like we have OH here, OH here, OH here, OH here. So a lot of areas where hydrogen bonds can be formed and leading to being dissolved in water. Citric acid is also slightly reactive when exposed to fire. If high amounts are exposed to skin for long periods of time, it will cause irritation, hives, and swelling. And like I said before, physical form will be a crystal or a white powder. So you see that white powder here. And then the overall function of the molecule is preservative in foods. It's also used in medicine. It will also be found in stuff such as soft drinks and candies, just as a flavoring. And then it can also be used as a disinfectant and laundry detergent. Also will be found in shampoos. So, like I said before, citric acid is not a very strong acid. Low amounts of it can actually help humans in skincare. So it will be found small amounts in products that help kill dead skin cells, declog pores, and adjust the skin tone. And it will actually be put into skincare products to help adjust the pH levels of it. And then citric acid will also help helps people in certain ways, but again, it's not needed for survival. It's more of a commodity. So, again, preservatives in foods, it will be helped in stuff such as skincare. It will also be found in laundry detergent and shampoos. So basically in those areas, it just helps to adjust the pH, which will help them work more effectively. So it's used for personal hygiene and for your food lasting longer. So more commodities than necessities. And then some biotechnology for citric acid is its use in medicine. Mainly citric acid is added into medicines to help with kidney problems. So citric acid will help people's pee be less acidic, which will help with avoiding kidney stones. Citric acid is not harmful to the environment. It will actually help the environment, if anything. Citric acid helps enhance the Krebs cycle, which we'll be looking at in class in the next couple of days. Basically, the Krebs cycle is just a cycle that creates energy. So it basically helps photosynthesis in general. So basically, more energy means the plants will be more greener. So it is not harmful to the environment at all. It will just help plants grow. So that is the molecule in the research I did for the citric acid.